All right, let's start the Friday talk show with Uncle Ba-Thong. Good morning, good Friday, and good afternoon to everyone. By the way, today it's also something special. If I'm not mistaken, especially for the Asian, today is the fifth day of the fifth lunar month. Chinese is also called the Tuan U festival. The Vietnamese, they call it the Tết Đoan Ngọ, which also like special day where everyone, you can see in Singapore, they're selling dumpling everywhere. And actually, I get my dumpling yesterday night. I bought it. In Vietnam also, we are selling dumpling and we're eating dumpling as well, special dumpling. Okay, so 2 weeks ago, we talked about how to sell a diesel car. Unfortunately, I didn't record that talk show. And then I talked a little bit about the French car, and the car that I liked the most at that time was the Citroën DS. So today, are we talking about the car again? No, we're talking something related to the car anyway. So this is the continuation of how to sell a diesel car. But we know we cannot sell diesel car anymore. As I talked to you the last time, we are seeing more and more all sorts of hybrid car, but we see also more and more full electrical cars. So today we will be talking about electronics and electromagnetism. Electronic systems have become increasingly large components of the cost of the automobile, from around 1% in the 1950s to around like 30% in the 2010, which is 12 years ago only. But today, more and more, and I don't have exact but the numbers, but I would say easily one day we're gonna reach 70 to 90%. So modern electrical car rely on power electronics for the main propulsion motor control, as well as managing the battery system. And in future, autonomous car will rely on powerful computer system and an array of sensors around the car. It requires networking, it requires satellite navigation, and all of which will require electronics. Let me introduce Chixiang, my colleague from Simia team. I'm working from home today, but in the office, Chixiang is sitting just next to me. We are actually back to back. So Chixiang, welcome to the talk show on Friday with Uncle Ba-Thong. Tell me a little bit about electronics and electromagnetism.
Sure. Yeah. Thanks, Ba-Thong, for your invitation. Actually, today I'm also working from home, right? Yeah, as Ba-Thong introduced, I am sitting just behind Ba-Thong, and I'm one of the member in the industry process consultant team, working in Singapore office, so covering AP South. And I joined CST. All right. So the product that you are going to look at it today is called CST Studio Suite. So I joined CST back in 2013. And then, as you know, the Dassault acquired CST in 2016. All right. But I would also like to mention another product. It's called Opera. So in fact, under Simulia, there are two electromagnetic simulation tools. So CST Studio Suite and Opera acquired by Dassault in 2018. All right. So yeah, to give you some idea of what is electronics or electromagnetism, I think you all know, because we really deal with it a lot in our daily life. Take an example that you have this, right? Mobile phone. This is
we all use mobile
electronics.
phone today.
Yeah, this is electronics, right? And this is wireless. You see, it doesn't need to connect to any cables. All right, it is not like your LAN telephone. You need to connect to a cable, right? This is wireless. Wireless means it can connect to the internet through wirelessly through the medium in the free space. There are many more examples. The smartwatch as well. This is having Bluetooth, Wi-Fi, right? And nowadays you have the Bluetooth headset, your mouse, your keyboard, your laptop, and even at home, the TV, printer, all these things nowadays they are connected to internet, right? So there must be some transmitter receiver in the TV or in the device that is enable you to connect to the internet. And many more other examples. If you move out to the home, if you are driving nowadays, you are driving hybrid car or even an electric car if you are very rich, right? And if you are taking train, like Ba-Thong,
like Ba-Thong, you know, right? This car is electric car.
Yeah, good. Yeah, very rich. And if you are taking train, train is also kind of electrical device as well. They use electric motors. And let's say if you are talking about some natural event, lightning strike is also an event of electromagnetic, but it is a very harmful event. There's a very large electromagnetic energy that is shooting down to the earth, right? So, and another maybe commonly seen event is when you touch a metal handle at the door, right? Sometimes when you touch the metal handle, you get an electric shock, right? You listen a spark sound, right? This is also an electromagnetic event, right? So many different examples I can talk, but maybe don't go too much into it. You know, roughly surrounding us, we use a lot of electronic device, and there are a lot of electromagnetism happening surrounding us. And in the free space, everywhere surrounding us, there are electromagnetic propagation. You can't see, right? You can't see. And this is also why among all the physics that Simulia product have, we sell structural simulation tool, we sell computational fluid dynamic, and structure, you can feel the stress, right? You can see after the deformation, you can see the shape change. So you can see it for structural. And fluid, you can also feel it when there's a wind blowing on you. You feel the thermal heat, you can feel it. But electromagnetic is very special. You cannot see, you cannot sense, you cannot touch it, right? So this is why simulation for electromagnetic is so important, because we really cannot see it, we cannot feel it. So and simulation can let you see it, right? And then maybe in our domain, electromagnetic domain, we like to talk about frequency, right? This frequency is very important in a way that it really determine what kind of calculation method we should use. So we categorize it in general. There are three categories. It's either static, which means that the electric current or magnetic current, there's no change in terms of time. So this is static, like a battery. Battery itself is 1.5 volt. It is DC, right? So there are some application like using static application that we can simulate. For example, the touch screen in your mobile phone. If you know the term, our touch screen is normally a capacitive touch screen. So the touch screen is actually a static problem that we can solve. We can design the touch screen from the simulation. And another example of static means is actually the if you are using a phone with a leather casing, and some of the leather casing that allow you to flip over, right? And when you flip over, the phone is like detecting that you have flipped over, so it will turn off the screen, right? So that kind of flip casing, normally there is a built-in magnetic magnet. There's a magnet there. So in your phone, there is a sensor to sense this magnetic field. That's why when you flip it, it knows that you close the flip, and it will just shut down the the LCD screen. So this is also static problem. And then moving up, we have low frequency problem, right? Not high frequency, all right? Just three category, static, low frequency, and high frequency. And low frequency, the example is like our home, we have electricity running at 50 hertz, or depending on the country, there are some countries using 60 hertz, right? So these are typically low frequency application. And then the transformer, every power supply you plug in, there is a transformer in the power supply. This is also kind of low frequency because it is dealing with our electricity, which is 50 hertz or 60 hertz, right? And for electric car, you have an electric motor in the car. So electric motors is also kind of low frequency problem. Then there are many more low frequency problem, like if you go to library or shopping, a lot of the things that the items, because they want to prevent for anti-theft, so they put some RFID tag in the item or in the library books. So these are also low frequency problem. And nowadays you use your phone for contactless payment. You use NFC, right? NFC is also low frequency problem, kind of, yeah. And then moving up into high frequency, then we talk about a lot of mobile communication like 2G, 3G, now 4G and 5G, right? And then even Wi-Fi, Bluetooth, GPS consider as well. And also for car, in fact, you want to detect the environment. Some of the car even comes together with the automotive radar to detect anything that is nearby your car, right? That is also a high frequency problem. Some of the advanced car that they are using 77 gigahertz automotive radar. So these are high frequency, and of course they are even ultra high frequency like optical frequency. So these are visible frequency range, and there are many more other optical frequency applications, right? So this is actually the basic one that we categorize it. High frequency problem, low frequency problem, or static. And then in fact, in our domain, in electromagnetic domain, we can also come up with another three sector, all right? So make it total to 5 sector: high frequency or high frequency, low frequency or static. This is already 2, right? And then the other 3 category is like we also deal with compliance, all right? Electromagnetic compatibility, for example, EMC. So for every product, if you want to sell it, you need to be certified the product that can that do not cause any disruption to the surrounding, right? So that is kind of simulation that we can do, and we classify it as compliance or EMC, electromagnetic compatibility. And another category we have is more to deal with PCB, printed circuit board. We call it EDA, electronic design automation. So this is for example, if you are designing the digital signal, you want to send the digital signal over the PCB, you want to understand the pulse shape, whether it is sent out from the transmitter, and whether you can still detect it at the receiver at the same piece of PCB. As you know, the PCB, there are a lot of traces, right, linked here and there. So this is the EDA domain. And then the last domain is it's very small portion. It's called particle, all right? And particles is actually means that we don't really just deal with electromagnetism, but we also deal with particles. And this particle is like electrons or ions. So we can actually simulate these kind of things, the interactions between electromagnetic and particles. One example is actually from your household device. If you use microwave oven, all right? You use microwave oven, and do you know that what are the devices that generate so much of microwave energy in your microwave oven so that you can make use of that energy to cook things? In fact, there's a device inside the microwave oven is called Magnetron. So this Magnetron is a vacuum device. You use it, you power it with AC, the electricity, then it will generate microwave within your device. That is actually a problem where you need to use electromagnetic and particle in order to design this kind of structure.
Hey, Chiang, I got a question. So at the first, you say there are three bands of frequency: no frequency, static, low frequency, and the high frequency. Then the other two, you mentioned EMC and EDA, and even plus these particle studies. How does these latter three fall into the previous four categories? Or we don't classify as like EDA? Is it low frequency, high frequency, or static? How do we like differentiate this?
Yeah, that is the reason why in electromagnetic domain, we don't really classify it for the EMC or EDA as high frequency or low frequency. That's why we make them as a special category by itself.
Okay.
Because EMC can be high frequency, can be low frequency. Okay, and EDA also the same. We can be high frequency or low frequency. And particle, yeah, it's a mixture of high and low frequency. Yeah, so that's why all these three domains are quite special. We make it as an individual, all right, and they have their own way of solving the problem in terms of numerical method.
Zhexiang, I remember that a few years ago, with the introduction of the iPhone 4,
yeah,
customer was facing an issue with the antenna, and Steve Jobs said that you need to hold the phone in a certain way. Is it something related to signal interference, or is it the design of the phone?
That is more into the design of the antenna. As you know, connectivity is very important, right? For all the device that is, we have to connect it to the internet wirelessly. So which means we need antenna to transmit the signal out of the device, and also I want to receive the signal using the same set of antenna that is transmitted from the base station or from the Wi-Fi router, right? So for this iPhone 4, in fact, I don't know if you, I think Ba-Thong, at your age, you at the beginning when you use the mobile phone many years back, right? Maybe in 1990 somethings, you use the phone and you know that there's outside there's a stick coming out from the phone, and that is actually the antenna, right?
Yes.
And that is the old day of design the phone. And I think starting in 2000 somethings, and you see a lot more of the mobile phone. You don't see anymore this antenna.
The antenna, yes, we don't see the antenna anymore. Yeah.
Yeah, the antenna become a module, all right, and they normally pack at the very bottom of the phone, and it is packed inside the phone casing. And that's why our phone is actually at the front and at the back. We normally use glass or plastic because we don't want to cover the radiation, because the antenna is inside the phone. So normally you see the glass at the front, or even nowadays there are glass at the back and plastic at the back, right? And this is because the glass or plastic, they don't block the electromagnetic wave going into or coming out. And then what the iPhone 4 does is that they come up with the innovative idea, right? They actually shift the antenna from inside to outside. So the antenna is actually surrounding the metal rim. We call it metal rim. All right. And this antenna is actually like this. There's one piece of metal like this shape, and there's another piece of metal like this shape, and it connect. It doesn't connect. This is actually the key. It doesn't connect. There's a gap here and there's a gap here, right? So this one piece of the antenna is actually used for Wi-Fi, Bluetooth, or GPS, and then the bottom, another piece is used for cellular communication, right? So when we design these two antenna, they are not linked by any means. There's a gap here and here. So these two antenna, they actually doesn't touch each other, right? And the problem is when we hold the phone at certain way, or I think it's left hand, particularly for this iPhone 4, is left hand, and your palm is like touching the gap between these two metal strips. And then as a human body, our hand or our body fluid, we can actually conduct current. All right, our body, our hand can conduct current, and that's why when we touch the the antenna gate, we call it antenna gate, in the two metal strips, really we conduct the current through our human body. And what is happening is the antenna was designed for each of these purpose, right? The Bluetooth, Wi-Fi, and each of these purpose have their own frequency range, maybe 2.4 gigahertz, right? And then the cellular also have their own frequency range, 900 megahertz or 1.8 gigahertz, right? So once we conduct this current through our pump, the frequency actually shift, the response shift, because of we are adding some loading by using our hand. So once the frequency shift, when you making a call with your left hand, the signal really keep reducing until a point that it just dropped the call. Okay. So this is really a very shameful event for Apple. Yeah. At that point of time, I think they spend a lot of money to give away a lot of free pumpers, just to prevent your palm is really touching that gate, right? And this is a real story actually. For CST. We after this event, our colleague in US, they really go and demonstrate the use of the software and how you can analyze different scenario, like how do you place your palm, how do you put it inside beside your ears and left and right hand side, many things that you can do with the simulation. And after that, we got a very nice purchase order from Apple in US.
Excellent. I was using the 5G during my year-end break in France in December, and I realized that it was really fast and was quite good with the iPhone 13. Now, how does it come? I know that they come to the 5G and 4G. There's a lot of standard. Every country or every group of country have their own standard. So how company like Apple can check and make sure that their phone is compliant with the local 4G and 5G standard in the country where they sell or the country where you travel?
Yeah, that is actually the compliance, as I said just now, the EMC, right? Electromagnetic compliance. And if you are, actually all this compliance is set by certain regulatory bodies, all right? In different region or even some of the countries, they have their own organization. And when you buy a product, I have some example. I think you will see that in your product, there are some sticker comes with it or even printed on it. It's called FCC or CE. So yeah. I have this Wi-Fi plug. It's a smart Wi-Fi plug, right? And I don't know if you can see it.
Yeah.
Do you see the FCC and CE?
Yep.
This is actually the certificate that they obtain in order to sell this particular product. All right. Of course, in Singapore, we see mostly this safety mark. This is also another example, right? So yeah, and if you are from Malaysia, then you will be seeing CRIM, right? So different country, they have different compliance bodies to take care of this and issue the product, the certificate so that you can sell. And the main purpose is, of course, to prevent this device is making harmful stuff to our living. It can be our to prevent the over radiation and burning our human tissue, right? In the case of mobile handset, or they control it when your device, you are using your device, you don't cause any interference to your neighboring device. So I cannot say that I launch a product and when I make a phone call and someone beside me, their phone call immediately drop, right? Because of the interference. So these are the things that we can actually do simulation, right? To ensure that there is no too much of radiation into the body. In fact, there's a term called SAR, specific absorption rate. If you buy a phone, you can Google it. You know what is this specific absorption rate, which is the energy that is going into your human body, all right, and which will heat up your head, all right, and cause harmful to you. So these are the limitation, all right. A lot of regulatory bodies, they will imply a regulations. So you have to pass this regulation before you can sell the product. And this is very crucial because a lot of the company, they don't really do the simulation much better much early in the design phase. So what is the consequences is when they want to launch a product, they come up with their first prototype, all right, but they go through this EMC test, but they fail. And the problem is when you go through the EMC test, you only know the report from the report, fail or pass, right? You don't know what is the root cause of the problem. And then that's why we always advise our customer to use the simulation much earlier in the design phase, so that you at the beginning, you have a full control. What are the things that can cause the problem? And you can come up with a very robust planning in your design to do a lot of study for different cases. So in simulation is really, for this compliance is really an issue. And yeah, we always advise the customer to try to adopt this EMC practice as early as the design process.
Okay.
Yeah.
Good. So
just now you talk about the interference, just reminds me of something I haven't seen for many years, but when I was little, sometime when, for example, my parents phone their cell phone, when there's a call, there's an incoming call, and it's placed next to the TV, and you'll hear like
Yeah.
yeah, that kind of buzz, right? That's
Yeah.
because of some I guess it's some interference, right? But now we don't see that nowadays. Is that
Yes.
because now we can simulate and find those frequencies so that they can avoid such kind of interference? Is that an example that?
This is one example. Or in the past, when you receive a phone call when you are inside a car, you also will see the coming from the speaker, right? So this is EMC problem. And another problem is sometimes when you use your phone and there are some interference, maybe nowadays in the product you don't see, but when you test the product, sometimes the LCD screen, you will see a lot of flickering. The lines, you see extra lines coming out. So this kind of things is also kind of EMC issue. Yeah, the simulation is just to analyze where is the root cause, where is the source of this noise, and try to suppress it from the come up with method to suppress this noise.
all right. So EMC-OC is also another role in Simulia that we can provide to our customer, especially any products that actually today, any products you have, there are electronic components and they need to go to that kind of certification. So developing a good and reliable product from the aesthetic and mechanical point of view is not enough. Companies need to make sure that they can also sell legally their products from the regulation point of view as well. So with this, thank you very much, Sian, for helping us to understand the problem and how we can have a conversation with the prospect and customer.